Nowadays, more than 2 billion people still lack access to a safely managed source of water. My team at the University of Glasgow is helping to address this issue by optimizing biofilter technologies to provide affordable drinking water globally. My research focuses on developing sustainable water treatment technology for the production of drinking water. The current drinking water and also wastewater treatment approaches were developed more than 150 years ago, and they were perfect for highly densely populated cities. Unfortunately, they rely on high energy and highly costly technologies. And if these technologies are unsustainable for big cities, they become even more unsustainable when we want to apply them in rural and in remote areas or in low and middle income countries. In the past 15 or 20 years, research has been trying to find alternative and more sustainable technologies. Biofilters started to be heavily researched because they rely on probably the ultimate renewable resources, which are microorganisms. So microorganisms can treat the water by eating the compounds that we want to remove from the water itself. They are considered very sustainable and they are very low cost. One of the issues of biofilters is that sometimes they work and sometimes they don't. So far, we have treated the microbial communities as black box. We do not know exactly how they form, we do not know exactly how we can enhance their performance. Our research is to eliminate this guesswork and go deeper in understanding what are the fundamental mechanisms that allow all these different microorganisms to come together and form communities that are healthy and working well. The community at the top are the lucky ones that can choose whatever they want from a buffet of food. Obviously, they are going to choose the molecules that are more easy to be degraded and leave the more complex molecules behind. And so the community at the bottoms are the ones that are left with the leftovers. So they had to adapt to this condition. And we actually confirmed that the community at the bottom are actually the one using and preferring more complex organic carbon. One way that we can use this knowledge is to see whether we can train our communities to work with this complex organic matter, for example, pesticides. Filtration systems that rely on biofilters have been successfully used and applied in some South American countries. And one of my close collaborators are working in the University of Del Valle in Cali at the Istituto Cinara. They have optimized, designed, developed, and also built these multi-stage filtration filters that treat surface water, raw water, up to really high standard of drinking water. Together we have tried to make these biofilters more efficient, remove some particular contaminants such as pesticides, and also make them more reliable. When we unlock this, then we can apply this knowledge to different types of environment. For example, the Scottish Island. I think that the best experience in multidisciplinary and international research is learning from each other. Really gives you the opportunity to translate research into impactful work.